Okay, so it looks like we're at the top of the hour, and I think we'll get things started. So welcome everyone, and thank you for joining us on today's webinar. My name is Leah Oxford, and I'm the Marketing Communications Manager for ABB Energy Industries. Today's webinar will be on open automation, the digital transformation of industrial automation systems. Please note that as our presenters are sharing information today, the slides you're about to see are subject to change. ABB does not assume responsibility for errors or consequences of software or hardware described in today's presentation. So as I had mentioned, today we are presenting Open Automation, the digital transformation of industrial automation systems. Just a little housekeeping before we get started so that you know how to participate in today's event. On the screen, we've taken a screenshot of an example of the attendee interface that you'll see on your screens as well. The control panel hides automatically when it's not in use, and you can move your cursor to bring it back. You have the opportunity to submit questions to today's presenters or by typing your questions into the Q&A box of your attendee interface. You can send your questions at any time during the presentation, which will last approximately 30 to 35 minutes, and we'll collect these and address them at the end during our open Q&A. If you cannot find the Q&A in your meeting controls, then click on the controls button with the 3 dots, and then you can select Q&A. This adds the Q&A box so that you can type in your questions. And a reminder to all attendees, you are on mute mode for today's presentation, and we'll also be recording it. And the presentation will be provided to you tomorrow for your reference. So at ABB Energy Industries, we like to start every meeting with a safety moment. And this is a reminder to stay healthy during the ongoing pandemic. So a few quick points to note. Avoiding close contact and putting distance between yourself and other people, making sure to cover your mouth and nose with a tissue when you cough or sneeze, or use the inside of your elbow, and stay home if you're sick, and make sure that to wear a face mask where applicable and to follow your country guidelines. We have an image on the right, which just illustrates how the simple act of washing your hands can be one of the most effective ways to prevent the spread of infection. So our presenters today are Jörg Schubert and Jonathan Schott, and Jörg Schubert is our Division Technology Manager for ABB Energy Industries, and Jonathan is our Global Product Manager for our DCS platform. And you can see on the right the agenda for today, so we'll talk a little bit about market forces, standards and initiatives, the demonstrator, as well as some of the benefits, and then we'll end with the Q&A. So with that, I will hand it over to our first presenter.
Yeah, thank you, Leah. I would like to start a bit. And when we talk about open automation, today I would like to put this in the context of the energy industry identity, touching life, driving innovation, and thriving together. I think talking about open automation, I think it's very important to note that we have spent over the past years and basically started this from the very beginning when we designed our systems. The goal is to allow plant optimization being safer, smarter, and more sustainable. So even before we talked about digitalization, I think ABB introduced something that's named Aspect Objects, which was our digital twin. We have spent a lot of effort in utilizing open standards. And overall had with all our work the goal to make the automation solutions helping to reduce overall lifecycle costs for automation facilities. So talking about open automation today is nothing that is kind of new to us and something that has just recently been introduced. I would say it is part of our driving for innovation fabric in our genes, and we have been pushing for that for a long time. The reason for that clearly is that we are seeing the markets moving. We have, looking at the different angles where automation does play a role, we are seeing from the market as ABB the push that the workforces in the plants are kind of aging, they are retiring, new people are coming in, older people are moving out, which leaves a skill gap, and new people need to be trained and get up to speed. That's clearly one of the challenges that we are seeing by the changes in the industry. At the same time, a lot of our assets are aging. The systems are getting old and need to get a renewal. We see more and more need, especially when you look at how the public is pushing certain topics to produce even more safe and more secure and have our operations performing more reliable than ever before. At the same time, I think during the past years, we could also see that new technologies are moving in. But at the same time, we probably also noticed that getting some of the new plants in production was probably increasing some of the costs compared to what originally has been set. So long-term projects, large mega projects had issues to handle cost control. And we have also seen that some of the new technologies introduced, just referring to the cycle that we see the past 10, 15 years on operator stations compared to the very past, we are way more exposed to the change frequency that the consumer industry is putting at us as we are using something like Windows as an operation system. So our lifecycle cost for maintaining the systems is for sure impacted by that, and that's also a driving trend in the market to get a better grip around this. At the same time, cybersecurity, let's say 20 years back, wasn't really on the radar at all. Some of the systems originate from there. Since a couple of years, 10 years maybe, that has become more and more into focus. But at the same time, as systems do have a long life cycle, not all of that has completely been embraced. So cybersecurity concerns are for sure more and more driving forces from the marketplace. Not the last because that we have more and more data flowing from the DCSs into information technology environments, office networks. That is changing the attack surface that we have from an automation point of view, and we clearly have to address that. And then last but not least, for sure, the operators of the plants, the end customers are seeing the pressure of global competition and cost reduction. So this is a set of the things that makes us stay awake overnight. Not all of that necessarily is how the Open Process Automation Forum is seeing it. This is the topic of today. But when we look at open automation, we can see clearly that the Open Automation Forum is trying to address some of the items that we are also seeing as market driving things. And the key motivation for giving life to open automation was for sure operations cost, and by that securing the competitiveness of the customer operating the facility. So the open automation's motivation is to make sure that the overall lifecycle cost for the equipment is going down by introducing some of the technologies that open automation stands for. A clear motivation of this push was probably coming from automation systems that are not as open as I would say the ABB systems are. Some automation systems are very closed, extracting data, getting new capabilities in those systems have been a struggle point for some of the people founding the Open Automation Forum for years, and that has been so preventative for acting competitive in the marketplace that this was a strong motivation to push out of this. And then for sure, the marketplace is changing. So a third aspect that we are seeing the Open Automation Initiative is that looking at the automation system and making them secure as an afterthought from the outside in, basically, that is something that was okay probably for the past years. But now we have more and more demand to easily extract data. We are moving with our technology into network-centric architectures. So kind of getting from one layer to the next layer on the one side becomes on request as a clear requirement easier, and at the same time it's for sure changing the threat profile that we have. So taking security as afterthought is not sufficient anymore. It has to be built in by design into the architecture, and those elements have been clearly driving what open automation wants to accomplish. So I think if we take a look and not only focus on what the Open Automation Initiative is doing, but what also we have done within ABB, you can clearly see that, as I said in the very beginning, innovation is key to what we are doing. The EN identity is clearly based on this, and you can see that a lot of things that are today associated to open automation are existing features, functions within the ABB automation solutions. So for us, going forward with open automation and joining the Open Automation Forum was an incremental step, not a revolutionary. It fits very well into our strategy. And just to mention a couple of the things that we have done, I think we have significantly changed the way how we update facilities when it comes to the DCS. In the past, lifecycle cost imposed through system version changes, often enough driven by outdated Microsoft operating systems. This process has become significantly reduced effort-wise. Instead of doing this as a major undertake, we can now have this executed from one centralized workplace, push it out to the entire system and lift the system node by node from one version to the other, while the system as such remains online and you can continue producing. We have embraced virtualization so that the dependency to PC hardware revisions that clearly have a quite different life cycle compared to what we see as a need in the automation market can be handled. So you lift the solution as such into a virtual environment and you become independent from the PC hardware if that supports your environment, yes or no. We have been very early utilizing Ethernet-based technologies, not only as communication between controller and workplaces. We have also supporting this in the field. Ethernet communication in the field was always in focus. For sure, some of the low-speed buses were clearly not Ethernet-based, but I think we're getting there, and the change is making systems more network-centric. We have done this in the very beginning by utilizing field bus foundation technology with the high-speed Ethernet. We have introduced electrical integration based on 61850 Ethernet communication or Profinet or Ethernet IP. And we have now also connected our system I/O, regardless if multi or single channel, to the Ethernet so that we have a network centric I/O solution that helps us to distribute the I/O points in the system as needed. Operator effectiveness, and you see this in the upper picture here, clearly is one of the key differentiators of ABB solutions. Extended operator workplace that you can see here, where few operators can handle in a very human-centric manner. Large parts of the plant are helping to operate plants more safe and more efficient. From an automation point of view, going back down here, different technology trends have been supporting the openness in the past. Some industry parts were talking about modularization. So instead of building monolithic facilities, they were thinking on, okay, we produce only for a limited amount of time a certain product. Would be good to have the entire plant more modular to rearrange and then produce the next product on the same thing. similar to what we see in manufacturing automation. And here, technologies like modular automation have come in, where you have automation, description of the automation in and package, and the system of ABB can kind of take this. You have process graphics and the need for peer-to-peer communication, well described in these NTPs. So third-party package integration comes significantly at lower costs compared to the way we have done this in the past with bit banging on third-party integration. Cybersecurity, we have been very much involved in IEC 62443, which is the cybersecurity standard for the industry. I would say certification is breaking ground now too, so we are on a process on not only having 62443 compliant solutions, but also have externals testifying this. And as we are moving to network centric, and you talk about cybersecurity, one can question how the proprietary field buses like Profinet, Ethernet IP, Modbus TCP are kind of addressing this in the future. And for us, the path forward clearly is to utilize OPC UA on as many as possible of these layers, because it has built-in cybersecurity, does support peer-to-peer communication and client-server communication. So OPC UA for ABB is a fundamental building block of future system architectures. It helps to integrate third-party equipment in a very efficient way, and also helps to extract data that shall go into the digital world, for instance, in a very sufficient and safe manner. Receiving end for this would be the digital side of this data extraction, and here ABB has just quite recently released their edge technologies, so that you kind of leave the OT environment with your DCS and you enter the IT or the office network through an edge device that then makes that data available for further digital analytics that you want to run on it. So these are a couple of things that ABB has done to support openness, to address these market trends, and also some of the items that the Open Process Automation Forum has put up as one of the key topics. But Jonathan, I would like to hand over to you now, and maybe you can tell us what the Open Process Automation Forum is doing and how they are trying to address this in form of standards.
Thank you, Jörg. Good morning, everyone, and good afternoon, everyone. I'm happy to guide you through the major standards and initiatives in the area of open automation. So, as you might be aware, there's multiple initiatives currently going on in several industries, some driven by customers, some driven by vendors. And these are the three major initiatives that are currently seen by us. There's firstly the Open Process Automation Forum, and we will be going into more detail about this in the later part of this talk. The focus of this is actually integration of existing standards, because they don't want to invent something new. They want to put together what is already existing, maybe in a new way. And the main focus there is flattening of our typical level 2 and level 3 system architectures out of the automation pyramid, which encompasses the PLCs, the DCS, and also the MES systems. There's several guiding principles, and they're quite important. And it's all about interoperable components. The meaning is it's not enough if it's just open or anyone can use interfaces. They need to be interoperable by design. As Jörg has mentioned, it's quite important security, and security needs to be there from the beginning by design and not bolted on later on. Another point is, of course, portability, because also, as Jörg already mentioned, some systems have not been that open in the past, and so being able to port configurations and software to other systems or later versions is very important. The outputs and products needs to be commercially available, and this is also very important. It's not enough to create a standard, but you also need to put together like a business ecosystem around it. Also very important is that multiple industry sectors are actually covered. Of course, the OPAF is driven, has been created and is driven by oil and gas and also chemical companies in the beginning, but in the meantime, there's over 100 members from all industries, so it's not focusing on one industry segment only. On the other side, it's important for vendors to really jump on a standard. They need to be able to protect some of their intellectual property, and that is also an aim of what the OPAF wants to do. And again, there needs to be a market. And this is also the reason why the OPAF is not creating only a technical standard, but also has a business working group focusing on actually creating and driving a commercial ecosystem where suppliers, system integrators, service providers can exist and make use of the standard and benefit from it. Then there's the Namur Open Architecture. Namur is a European-based society, mainly in the chemical industry, driving a lot of standards in this area. And out of this came the open architecture definition. Its focus is actually on an information model, first of all, and it's for integration of real-time device information. And the main driver is actually to get better at monitoring and optimization applications. So the problem today is that it's usually very hard to get information out of DCS systems, especially if you want to get them from the source, right, from the I/O channel or wherever they are occurring. Always there's some routing, there needs to be programming changes, and that is a guiding principle there. It should work for new and existing plants, and it should not compromise safety or availability. But at the same time, you get open interfaces to extract the data wherever you need it for your monitoring and optimization applications. But it basically leaves alone the core DCS system. Then there's the modular automation, also born from initiatives by European customers and vendors. And its focus from the beginning was actually providing a more standardized way how to automate modular plants or modular processes inside a plant. And the main output there is it's based on the Namur open architecture to some extent, but the main output there is the so-called module type package, or MTP, which basically is a definition how control functionality, field level functions, and more can be integrated into higher level supervisory systems. It also defines an orchestration layer, and it actually provides the flexibility to rearrange your production modules as you want without reprogramming the whole system. But now let's head into details of the OPAF. So once again, what is the OPAF? The OPAF is a forum, it's an industry organization, and it supports actually developing the open process automation standard. It's hosted by the Open Group, and as I mentioned, there's a lot of industry representation. There's end users, system integrators, suppliers, individual experts, everyone is in there. And the approach that is taken by the Open Group actually has been proven already. It's not a new approach. They have used it in aerospace or telecommunications with other successful open standards that they put in place. And this is very beneficial, actually. And it's a unique way to collaborate actually between end users, suppliers, and system integrators, because there's not much room normally that suppliers like us, Siemens, Yokogawa, Rockwell, sit together in a room and discuss on a technical standard. So this is very unique. The scope you can see on the right side. It's really about the main DCS or PLCs, including some I/O aspects, some advanced control aspects. Explicitly, safety integrated systems are not covered so far. Higher level business systems as well not. Individual field devices on the plant level are as well not covered. HMI is also mentioned there. Of course, it's an important part, but the standard will also not really define HMIs, but of course the interfaces that the HMI will need to consume. Okay, let's continue. So, what are the deliverables by the forum? The main thing is the so-called OPAS standard, the Open Process Automation Standard. And again, the key elements are crucial here. It's about openness, that's one thing. Interoperability, this is very important, because just having the standards available, and some of them have been around for decades, does not provide an interoperable system per definition. A lot of you might have learned with other standards in the past. Security by design, again, is very crucial. Most of the existing products today had that in a way or another bolted on later on. Then secondly, the ecosystem. As I said, it's not enough to just throw a standard out there on the market. You need to have a thriving ecosystem where everyone can exist and where all the traditional roles can continue to exist, but also maybe it opens up doors for additional roles and additional possibilities. And secondly, it needs to be a community, because if that standard is just born out of a few people, it normally doesn't fly. Very important there, the OPAF does not try to write a totally new book on automation. It's about integrating existing standards, and you can see that on the right side. There's collaboration with all standard organizations out there, from OPAC Foundation, the ISA, the ANSI, ISO, IC, NAMUR, and ZVEI. ZVEI hosts the modular automation so far. So wherever something is available, it's reused, but how it's going to be used is defined in a way that these key elements are actually provided. Testing is the other important factor, because a standard is good, but you need to be sure if you buy a product that is really compliant to the standard. So independent testing by using established test labs is another goal of the OPAF. And in the end, if a product will be OPAF certified, it must pass 100% conformance test. There is no little bit of OPAF conformance. You pass it or you fail. I think that should actually provide a lot of trust for anyone that is really trying to build a system out of OPAF conformance products, because they have been really tested 100%. Please continue. So you might have seen this picture. This is a standard picture from any presentation about the OPAF, and it actually does not show an automation system, as many might see. It actually provides an overview of all the components that you can build with the OPAF standard. So these components will probably never be combined in this way together, but out of these components, you can build your actual automation system. And you see the yellow parts, which are 100% covered by the OPAF standard. And then you see the other parts, which contain blue elements, and blue is non-conformant components and devices. But everything in the end can work together, because the OPAF provides a way, of course, to integrate purely conformant products on the left side, with the main device being a DCN, a distributed control node. But a DCN can also be a gateway, as you can see in the center, to existing DCS system or PLCs. And with that, it's very easy to extend existing systems. You can build in the OPAF communication interface into existing products, and then they appear like a DCN to the overall system. You can, with the same way, also, of course, add your safety or other systems to the network. And very importantly, you can also, of course, if you have larger devices or platforms, add a complete DCN, a virtual DCN, a software DCN to it. So it's possible for any kind of environment on the field level, but also up there on the business level, and wherever you need to communicate, to be on this OPAF connectivity framework. And while this shows a typical network-centric architecture, it's also very clear it's not dictated or demanded that your network will be really flat in the future. It's a possibility, it can be done, but it can also be existing in multiple layers and still be OPAF compliant. The OPAF does not dictate that. And what might be new for some applications is, or some projects or end users, is the advanced computing platform, where it's really foreseen that it does not only run extended applications as it might do today. The OPAF defines also the execution engines in a way that you can run your control in such an advanced computing platform. Okay, so this was a very, 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 yes, please continue. This was a very, very brief run through, and there's a lot of content to tell about the OPAF and the other initiatives, but just summarizing quickly the benefits, it's very clear, Jörg mentioned that before, improved operations is most crucial for end users. You need to be able, if you are currently using a not so open system, an older system, you should have the possibility to easily migrate or upgrade your systems. And that is a major thing that the OPAF wants to ensure. And at the same time, basing it on certified hardware and software to rest assured that it's really working together and is interoperable. Due to its openness, it's clear you can have a multi-vendor system. Components should interoperate together and should be exchangeable. With that, you're quite future-proof, and you are able to select the best-in-class functionality. However, on the other side, it's also clear you don't need to choose a different vendor for every functionality. And we as ABB aim, of course, for the future as well to provide you a complete system based on the OPAS and other initiatives. And but you have the freedom to choose. And again, security. Security is a benefit, because having it designed in from the beginning is a major difference and allows you to be certified to even higher levels of security that is possible today. So all of that actually makes end users realize very significant values. And this is not only on paper, and this is not only a dream. As Jörg is going to show you in the next section of the talk, there is real initiatives out there where people have put together already systems based on these initiatives and standards.
Okay, thank you, Jonathan. Yeah, as Jonathan mentioned, we have been active in the open process automation forum, I would say, from the very beginning. We have been founding members in there. On the one side, you would say, well, this is kind of breaking the DCSs apart, because you become more open, and you can pick and choose best of class components. We still think that is kind of not weakening our positioning, this is strengthening it. We as ABB have been exposed to the need for bringing in best on breed components through basically all our automation lifetime. So for us, it's a natural continuation. And when OPAF was formed, for us, it wasn't really a question if we should join there. We have been based on open standards. We are utilizing open standards and integration of components that provide a very helpful function into an overall system has been base job of what we have been doing. So what you're looking at here is after we have been in the founding team, after we have been contributing to a very early demonstrator, the industry moved on and they are doing proof of concept solutions in the different areas. And as I think it originates somewhere from the oil and gas downstream area, this entire open process automation initiative, we have been in this particular case here being involved in proving that it is not only applicable to the oil and gas, but also for other markets. And what you're looking at is a demonstrator that was built here for the chemical industry. As you can see on the top, the customer behind this here is BASF, and they have shown this at their chemical organization annual assembly, the Namur assembly last year. ABB did this with together with BASF and a couple of other vendors. And when it comes to the architecture that Jonathan has shown before, you would see DCNs down here from a third party. You see connected field instruments down here. You see a PC environment with virtual distributed control nodes, DCNs up here. And you see the HMI portion of it. So it's a little demonstrator for a chemical application. But in addition, we pushed the needle a little bit further, because in this demonstrator, we also make use of the modular automation concept. Actually, each of these DCNs here is automating one of these reactors, these glass reactors, where you have heating and mixing functions in there. So the entire unit of the automation component plus the physical equipment plus their devices described in a modular type package. And in addition, we have arranged those 4 to an overall facility that would be or is able to produce a chemical recipe. And we have kind of proven that the open automation technology approach is not only applicable for the oil and gas markets in downstream, but also for the chemical, and would even help to simplify the way how continuous and non-continuous processes, like in this particular case here, batch process in the chemical industry could leverage this. The interoperability between the components, the different DCNs, and you see this on the next slide in a picture more detailed, is based on Ethernet. But as I said, we have tried to combine the open process automation feature functions with an approach for the engineering through the modular type packages, so that whatever was available as automation solution in the package could be used in a very efficient way for the overall orchestration. And let me show this in a little bit more schematic drawing here. We have down here these process equipment assemblies, basically the reactor, the glass pot that you have seen there on the other picture, with the automation unit. The controller as such here is in DCN that talks to the open process automation connectivity framework. So based on the architecture that Jonathan has shown before, the network and the DCNs, physical DCNs, 4 of them, but we also have on this advanced computing platform up here and virtual DCN. One could also say it's a soft controller, virtual distributed control node that operates on a high available advanced computing platform and is exchanging data with the DCNs, the physical DCNs connected to the network. So the communication between the units all based on OPC UA, so that you have a cyber secure communication on your open process automation system communication framework. From a visualization point of view, we had an HMI there fetching the data from the different DCNs. And I think where we pushed the needle a bit was for sure on the engineering side. The open process automation standard that was out at that point in time was the version 1.0. It talked about interoperability, but it didn't talk about how you would engineer this. But if you want to run plant automation in an efficient way, you also need to engineer it. And that engineering also needs to be a slick process. So what we have used here is a standard that's now also in the discussion with the OPAF team. We have taken this modular type package approach where you would get from a third-party vendor, like in this case, the vendor for the DCN, a description of the automation that's running in here, the associated process graphics, and you can import this into an engineering tool, which we name the orchestration layer. And then we have been able, within this engineering environment, to make these different, and keep in mind those were reactors, so little tanks that you could heat, mix, empty, fill with different ingredients. So from here you could arrange how these different process assemblies would interact with each other, and you had a supervisory control on top here that was then more or less running the recipes. So a typical chemical facility for a discontinuous process that is batch operated procedure, and utilizing this module type package approach for handling the engineering. So OPAF technology taking an additional standard into it to address the engineering approach. In the meantime, OPAF is evolving. Second edition of the standard has been released early this year. So there's more on the engineering side, but I would still say a longer way to go. And the module automation approach is part of the discussion right now with the OPAF. In addition, in this demonstrator, we were also taking care of what you have seen in the general drawing of Jonathan, export of data to, in the past, one would have said level 3, level 4 applications. That's done here by an approach that the chemical industry is going for. This is the NAMU open architecture approach, where on the level where the data comes, you have an extraction path and cybersecure extraction path into the cloud. So we had a gateway device here where on the one side field instrument data for condition monitoring was extracted, but at the same time through this path we could also get plant data from the OT world into the IT world. So such a demonstrator was a good proof that the technology is not limited to a particular industry. It is applicable across the industries. And then kind of to move on, as I'm said in the very beginning, our identity is also about innovation. So we have continued since on pushing the needle forward, because for years we have been utilizing open technologies, open standards, and we think that right now there's great opportunities to linking all these things together. And another initiative that we then had in February this year added to this approach is shown here. So you could in this picture probably say on the upper right side, including this PLC, that is more or less the same scope that you have seen before with the other demonstrator. It was an OPAF or open process automation system with an advanced computing platform with virtual DCNs on it, an HMI and engineering, and the DCN down here. What we are adding in this is that we are making use of the Ethernet technology going all the way through to the connected field instrument. So instead of having a DCN with local I/O or a gateway DCN that would fetch data from a remote I/O, here the Ethernet communication goes all the way into the field instruments, and the blue cable is not by accident. What we're talking here is what is named the advanced physical layer. It allows to stretch the Ethernet into the field and supporting the deployment in hazardous areas, including instruments that are sitting in zone 1. So you talk Ethernet into these APL switches, and then you have spur connections, and you see several ports here, and each of these ports would connect one field instrument to the assembly. So now your I/O suddenly becomes directly available on the system network. And to kind of tie this into the open process automation story, this instrument was also running an embedded OPC UA server, which is a communication mechanism that we're using in the connectivity framework of the open process automation standard. So here you see an enhancement again of what the OPAF is focusing on right now by adding the field instruments directly into it, by bringing the industrial Ethernet all the way down into the hazardous areas or non-hazardous areas with OPC UA servers running on the instrument. And with that, data could have or has been used on the one side in the DCNs for process automation, but at the same time we could access data out of the devices directly on a local operator panel, or could extract this through an edge device into the digital world. So two examples where ABB is joining pilot installations where OPAF or open process automation technology is deployed in different use cases. Jonathan, a couple of his colleagues are representing us within the open process automation forum. So from an ABB point of view, this is very much where we think the industry is going. We see this as a big chance to combine all the different initiatives that are happening in the market right now. We named the modular automation. We talked about field buses all the way down into the field. So all this, we see a great chance to have this all coming together in one solution, because the the key precondition here for being successful in the market is the acceptance by the end user community. And that's why we are so eager to get this all converging into a common approach in the system architecture. And from a system vendor's point of view, we clearly think that there will be probably an in-between step where customers would say, I want to have an open system, I want to have it coming out of one hand, but it needs to be open that in addition to what my one system vendor or system integrator is delivering, I can complement this with best of class components that are coming from others. So our day-to-day life is the system integration, and we think the open process automation is just paving the road through making use of more standards in that area and driving it. So kind of the benefits that we clearly see on our side for the end users, and we project that they also resonate with you, is that this standardization of the way we handle the equipment, still allowing meaningful segregation of applications, and the dynamic scaling that we reach with the openness to have small things addressed, but also large, is clearly the path to go here. So with that, I think I would like to move out of this. We see open automation as the key for the future to address the market trends, make sure that the production costs are going down to where they need to be, and the technology will help us to reduce the risk and improve execution schedules. With this, I would like to hand over to Jonathan again and ask him, how are we moving forward from kind of where ABB has been in these piloting activities, and how is the OPAF now moving forward from where we stand right now?
Thank you, Jörg. Yes, as Jörg mentioned, ABB is an active member in the OPAF as a system integrator, but also as a supplier of products. And I'm representing ABB in the technical working groups together with colleagues. We are currently working on the version 2.1 of the standard, which is planned to be released latest Q1 next year. And this is considered to be a major breakthrough because for the first time, all parts of the standard will be available so that you can really build or start building conformant products and think about system designs based on these products. Major deliverables this year have been the certification policy, which is crucial to be able to certify the products by external labs. So ABB will continue to support the OPAF with people, with knowledge and anything possible. But Jörg, can you elaborate what ABB specifically will be doing next out of that?
Going forward, we will continue pushing in that direction. Our system architecture will embrace the elements that we have been talking here to the overall system layout. So you will see moving forward open process automation technology being embraced in the product families of S Plus and 800XA. So going forward, our roadmap for the years to come, and you can see here standards evolving. So you will not see OPAF in ABB causing an step change. I would say it's a continuous evolution. At the end of the day, doing a step change, but we want to move our installed base forward with it, and we will not turn around and do something fundamentally new and different by leaving the installed base behind. So for us, it's crucial that the installed base that we have today sees these new trends coming in as an evolution and not as an opening for a complete new system. So we want to bring the installed base forward and enabling it for embracing this technology. That's a roadmap for the years to come. And with this, I think I hand back to Leah to take care of some of the question and answers here now.
Yes, thank you, Jörg, and thank you, Jonathan. So we'll take some time now to review some of the questions that have popped into the chat. So just a reminder, please be sure to type your questions into the Q&A box on your control panel, and we'll try to get through as many as we can today. So we have one question. This is from Craig. So Craig's question is, I assume that the DCN B10 through B40 for PEA equipment can also be equipment from other DCS manufacturers. Is this something that we can enable or can be enabled?
Sorry, can you repeat this, Leah? I'm not sure if I forgot the question. Yeah.
So can we assume that the DCN, so B10 through B40 for PEA equipment, can also be equipment from other DCS manufacturers?
Yes, that's exact approach here. In this particular picture that you have seen, I probably should have said this, these DCNs were non-ABB DCNs. In this particular case with BASF, the companies involved were Phoenix Contact, it was Wind River, and it was ABB, and a couple of instrument vendors. So in this particular case, the hardware that you have seen was PLC solutions from Phoenix Contact, but it could have been on the first reactor something from Phoenix, on the second something from ABB, and on the third something from. Our philosophy clearly is to say we would use best functions here. At the end of the day, the differences between the DCNs aren't too big, so we would probably assume that based on the feature function that you really need, you make your choice, and we would not see installations where you have really 5 different DCNs. You would pick one and go into this, but then for the next type of, let's say, not on the reactors, but maybe somewhere on your tank equipment or whatever, or what other units you have, you might make use of different DCNs. That's clearly the goal here, to be more flexible than we have been in the past.
Okay. There's another question about how the application engineering is done. So if you have products from several DCS suppliers, do you need to engineer each in their own language, or is there a standard language for application engineering?
Yes, I will take that one. Thank you, Arte, for asking. Actually, this is a very good question. And there's a simple answer. In the end, right now, the products, probably also the future of each DCS vendor will firsthand need to be engineered by their own tools. But what is very important, what is the difference from before, is that especially the second version of the OPAF standard is focusing on configuration portability. That means wherever you engineered your actual device, it is possible if you are OPAF compliant, to export this configuration, import it in any other vendor's engineering tool, and the configuration is understood and is working. So in the end, it doesn't matter which tool you're using. You can use the best-in-class tools to actually engineer the systems. Depending on the direction what the OPAF standard will be taking, it might either be required to still use vendor-specific tools to download a configuration, or the OPAF will even allow you to download a configuration to another vendor's device. That is a future road that has not been fully decided. But in any case, any configuration you're doing in some vendor tool is not locked in there, but it can be exported in a standard way so that it can be understood by any other tool.
And let me complement a little bit here. When we did do this pilot here with BASF, one of the reasons why we leveraged this modular automation component here was that this engineering wasn't addressed. And ABB, as being a DCS vendor, I mean, engineering for the plant is a crucial element. Why did modular automation help here? The answer is quite simple. In modular automation, you are specifying what's running in this equipment here with its local automation in form of services. So when you look at this physical equipment here, it has something like filling, it has something like heating, it has something like mixing, it has something like draining. So the key automation functions on the equipment are described in what's named this modular type package. So the actual logic is programmed with the vendor's tool. But it's done in a way where when the ABB engineering tool is importing these module type packages, number one, we are getting the graphic representation for what actually was meant for being the visualization for these different equipment types. And secondly, we know what feature function the automation system can handle, and it is state controlled. So from the orchestration point of view, we could easily now say from the supervisory DCN, open a valve, and then the logic down here was executing this until the valve was open, it was feeding it back. So the entire automation basically was handled here. The base functions were coming from here. So from this orchestration point of view, we have been able to put the plant automation together that was running there and creating the recipes. And being involved in this, I have to say, it was quite amazing to see how efficient that worked. We didn't have to go back in and do configuration changes down here. The base functions were pre-commissioned and supported. And then with the orchestration, we were forming the overall automation that was happening in the facility. So again, this was ABB in this pilot combining two things. Moving forward, Jonathan was outlining where we are going so that an engineering portability shall also be addressed in the future and on the open process automation side. Here, we are taking a shortcut by trying to push the needle with this modular automation approach. And I have to say, it was quite impressive to see how good it worked, even with third-party PLCs and handling that in a flexible arrangement where modifications to the plant automation was possible at any time.
Okay, thank you, Jörg and Jonathan. Another question, are OPAF and MTP complementary or incompatible?
So thanks, Anil. Actually, welcome to the audience. Anil is the director of the OPAF, I have to say. This is a very good question. I think Jörg has already answered that question mostly or partially, because they are, of course, complementary. They are by far incompatible because the OPAF is defining the overall building blocks for an open system, and it defines interfaces for configuration, exchange, interoperability. Whereas the MTP adds an additional layer on top of that, and that is known from software engineering as encapsulation in a way, because you encapsulate certain types of information and make it very easy to transport it through a system between vendors. And I think that is actually very well complementary. And again, I think it's just another layer on open automation, open architecture to utilize the MTP standard on top of what the OPAF provides as a foundation. So I think they work very, very well together. And we are currently working in the OPAF to bring these two worlds really together officially so that everyone understands how you can benefit from both of them. Thanks for asking.
Great. So we have 2 minutes left, so I'll have one more question and then we'll close up. The question is around, does OPAF address modern IT architectures such as serverless, Dockers, etc., which favor less dependency on the operating system and improves DevOps? Are there any plans to explore these?
Jonathan, I think you take that, yeah?
Yes, of course. If you go back to the picture, yeah, one of the architectures, yes, exactly. I mean, it is very clear, a lot of virtual DCNs are on this picture, and executing virtual control nodes, executing applications, porting them, it cries for concepts like containers, having serverless systems. Yes, that is foreseen from the beginning. It is foreseen that a DCN doesn't need to be a dedicated hardware box. It can run on any platform, an IPC, a huge virtualized center, whatever you want to run your applications, execution engines on. The OPAF has already includes definitions of all layers down to the hardware operating system layer. But right now we are focusing on the highest application layer, and the others will be explored at a later stage. So yes, all these principles are crucial for the success and the usability of the OPAF standard. And one topic of that is just started right now as well is the orchestration of all of that. That's right. If you have a lot of these containers, you need to orchestrate them, how they are running, not orchestrating your process, but your system. And these are as well topics that the OPAF is covering.
Yeah. Okay.
Great. All right. Well, thank you, everyone. We appreciate you taking the time to join us today. So after we conclude this call, you'll be prompted to fill out a feedback form. And if you could just take a few minutes to let us know your thoughts on our discussion today, it would be very helpful. So once again, thank you for joining us, and we hope to see you next time.
Thank you. Bye-bye.
Goodbye.